Good morning, good afternoon, good evening, wherever you are in the world. Thanks for joining me today for Kubernetes 101 episode 5. Today, we're going to pick up right where we left off in the last episode, which was we deployed Drupal to a Linode Kubernetes cluster, and we ran into an error because we tried to scale Drupal up, and it started running into this thing called the multi-attach error because the volume that Drupal was using to store files could not be shared across multiple pods. So we're going to get into that in just a minute, but I want to say make sure you stick around to the end of this episode today because there will be a live Q&A and there will be 5 book giveaways, and I'll talk more about that at the end, but be sure to stick around. You'll see why. Also, please feel free to say hi and where you're from in the live chat. It's always great to see. I saw people from at least 4 or 5 continents so far. Nobody from Antarctica has joined one of these yet, but there's still time for that. I'm sure they use Kubernetes with some of the scientific teams there. Anyways, please say hi, say where you're from, participate in the live chat. It's great to see everybody here today. And as I said, we're going to switch, or we're going to go right back into where we were last week. Last week, we ran into this multi-attach error. We tried scaling Drupal up from 1 pod to 3 pods, and then it tried to expand that deployment to have Drupal scale up, but it can't do it because it's using a Linode volume, and the Linode volume can only attach to 1 pod at a time and 1 Kubernetes node at a time. And this is a problem that we will run into in many different places. So, you know, if you're on Amazon, you use EBS. EBS can only attach to 1 pod at a time. OpenEBS, which is a solution to have like an EBS-like volume system inside of Kubernetes, same issue there. And if you use Linode volumes, which we're using here, it has that problem. DigitalOcean block storage, all these things have the same issue, and that's that they can only attach to 1 pod at a time. So I'm going to go ahead and delete this this deployment for now because it's not working. Last week also when we deployed Drupal, it showed an error message, and that was weird. And I had done it like 3 times beforehand and didn't have that. And I've done it 3 times since and haven't had it happen. So I'm guessing that it was just the live demo god of insanity has hit me last week. So anyway, it worked. It worked the 3 times I tested it before this. So that probably means things are not going to work today. But I decided to do everything live today because it's fun to have a little chaos in your life, I guess. I'm going to go ahead and delete the Drupal namespace from episode 4 that we created, and it's going to clear everything out in there. And while I do that, I'm going to switch over to a couple slides here. Now, please don't get intimidated. I don't want you to memorize any of this stuff. This is for illustration only. And there are some other options too, besides switching to a storage system that allows you to have more flexibility, like what I'm about to describe. There are ways that you could change your entire application. So you could tell Drupal, hey, store all your files into an S3 cloud-based block storage system like S3FS or filesystem. But if you're going to do something like that, you have to change your application. And a lot of us are in situations like, for myself, some of the projects that I was working on a hosting system for Drupal sites that are maintained by other people. We can't tell them you have to change your application. You have to change the way you use Drupal to fit our infrastructure. I said, you're giving me your site and I have to host it for you. And a lot of times, even if you're in the same company as the people that are hosting these things, a lot of times your teams are not integrated together. Some of us we are, and you can work together on different solutions, but a lot of us, you kind of get something thrown over the wall and you have to run it. So the solutions that we're going to talk about today are to help run Drupal using a file system that's shared, that has all of the standard Unix POSIX conventions, so you can write files to it and read files from it and stuff. It's not going to switch your application's block storage system, but that is an option. That is something that some people do when they want to run something like Drupal and Kubernetes. They change their Drupal application to work with a different type of file system that's not dependent on the fact that it can be mounted into your containers in the same way. But what I find that some people do when they jump into Kubernetes development is they go straight from a simple setup. They might have had 1 server or a couple servers with an NFS mount in them or something, and they go into Kubernetes and they're like, oh, in Kubernetes you use Rook. Rook is amazing. It's great. And I'm not saying Rook is not amazing. There's a lot of great things about it. For a lot of people, it is a great solution. But I want to show this slide and the next slide just to show that Rook is not a simple service. It might seem simple on the surface, and especially if you go to rook.io and look it up and see everything, it's like, oh, this is amazing. Everything is so beautiful and so easy. But there's a lot of complexity in what Rook does. Rook is basically, this is technically inaccurate, but this is how I think of it. It's kind of like RAID for a Kubernetes cluster. You have a bunch of disks, either physical disks or persistent volumes on your cloud provider, basically disk storage of some sort. And then Rook does all these different things for you. It will use OSDs, which are object storage daemons. It will run these little daemons that will manage your disks, kind of like little mini RAID array type things. All of those work together with Rook's metadata server, this MDS over here. And it works with the Ceph manager, the MGR here. It works with Ceph monitoring, and then Rook on every node runs an agent that coordinates everything together and makes sure that drives are mapped correctly. And then Rook itself will use the metadata server and things to build virtual drives for your cluster. And this is really powerful if you need it. If you don't need it, it's a terrible idea. But if you need it, the cool thing is your applications, Rook is kind of complex. It does all this stuff under the covers. In some ways, it's kind of like a ZFS or something like that, where you have to really know what you're doing with it if you don't want to lose data when you're working with it. But if you get it working, it's kind of amazing. It's kind of magic because you can set it up so that you can have volumes that can be shared across pods. You can have volumes that are just like EBS volumes, like attached to one pod. You can have high speed and low speed storage. You can have different layers of redundancy. Volume snapshotting and backups are super easy. So there is a lot of complexity, but it does enable a lot of functionality. So for some users, a thing like Rook is amazing and kind of a godsend for your cluster storage. However, both of these slides show that there's a lot of layers of things going on with Rook. And especially if you're just getting started with Kubernetes, I really don't recommend people dive straight in the deep end of using Rook or something like that. I often will set up a cluster, first of all, with nothing, no special shared storage engine. But once I need it, I will use something like NFS. And the reason why I say all this is I actually was going to use Rook in today's episode. But after I spent an entire working day trying to get Rook working in a way that I could demonstrate in less than an hour, it was impossible. And I could, but I don't want to do things where I leave you hanging or I skip over some important things. And with Rook, there's enough important things you can't convey all that in 1 hour. I don't think. If somebody can do that and share an episode with me that's 1 hour long that explains to somebody new to storage in Kubernetes how Rook works and how to set it up and get it running and in the end have volumes working, send me that and I'll give you a free copy of my book or something. I'll even sign a piece of paper and mail it off to you since the book is not printed in paperback form yet. But there were issues with it also when I was trying to deploy it into Linode and to Minikube, and I had to keep doing little workarounds and things, and I was just like, you know what? Not a great idea for a Kubernetes 101 series. I don't think Rook is a 101 level thing to set up in your Kubernetes cluster. It's more like at least a 102. And like I said, if you don't know how it works, I would caution you against using it. Just like if you are setting up storage and you want to use a RAID array, I talked about this in my episode of the Raspberry Pi Compute Module 4 series. I talked about setting up RAID arrays, and after this is over, I'll put up a little card over here that shows a link to that video that you can watch. If you don't know what you're doing with RAID, you're going to lose data. Even if you do know what you're doing, you're probably going to lose some data, so you have to have backups and a good recovery plan. But that's kind of like Rook for me. And some of the other systems, there are other systems in Kubernetes you can use, but often if a vendor tells you you have to do it this way, I would not necessarily trust them unless I know that vendor is going to do things really well with it and they have experience with it. So anyway, another option for some people is to set up Ceph or Gluster on their own This architecture that I'm showing you is a Rook Ceph file system setup, and it uses a Ceph operator that builds the Ceph cluster for you and manages everything for you. But again, if you don't know what it's doing, you need to learn how it works before you start relying on it for storing all of your important data. But all these things are pretty complex. On the flip side, what I typically do for my clusters until I need it is use NFS, because NFS is a little bit easier to understand. For my needs, often I just need to make sure that the storage is reliable, but I don't need 100% or 99.999% uptime. If the NFS server itself has a few minutes of outages here and there, it's not going to be the world ending. And I typically also try to make my websites work, even if the storage is gone, using, you can have images not load for a few minutes, or you can have timeouts and things like that, and graceful recoveries. And Drupal does a pretty good job with that. A lot of PHP applications do, but if you build in another application, in another language, you need to make sure your applications can handle that kind of outage. But anyways, I typically use NFS, and the reason for it is it's a lot simpler. There's, if you have an external NFS server, it could be that Raspberry Pi RAID array using NFS over your network. But if you're building production applications in Kubernetes, especially in a cloud environment, I wouldn't rely on a Raspberry Pi running in your home office like I do. But anyway, you have an NFS storage server running somewhere, and then Kubernetes can attach directly to that using the NFS Client Provisioner. And I'm going to talk a little bit about how that works in just a minute. But you'll need an NFS server running somewhere. And the Client Provisioner, what it does is it connects to that server, and then any time that an application that you have requests storage, it will create a folder in your NFS share for that application. In this case, it'd be Drupal. It'll create a folder in there, and it will create a persistent volume claim inside of your Kubernetes cluster, and it'll allow you to attach that to as many pods as you want. Obviously, there's still scalability issues here. If you're going to use one NFS server for 7,000 applications, you're going to have some issues that you run into, and we'll talk about some other alternatives there as well. But in this case, we're going to need to have an NFS server running somewhere. There's another way that you can do this. You can use the NFS Server Provisioner, which is actually now known as the NFS Ganesha server and external provisioner. It's funny, about a month ago, they started moving these repositories around that have these different projects. So there's the NFS Server Provisioner and NFS Client Provisioner. That's how they used to be known. The Server Provisioner would actually run NFS inside your cluster. I don't particularly like doing that, just because I like to have my storage separate for manageability reasons and backup and things like that. But you can do it that way, and there are ways to do it that way. Let's see. But anyway, it was actually moved to be called now the NFS Ganesha server and external provisioner. But either way, if you search for things on Google, you're going to find it be called the NFS Server Provisioner, so just be aware of that. The NFS Client Provisioner is now known as the NFS Subdir External Provisioner. And somebody asked in the chat if the NFS server needs to be mounted on all the worker nodes. If you were going to use NFS provisioning or NFS storage directly in your Kubernetes definitions of like the Drupal definition, you would do that. But the cool thing about the Client Provisioner is it manages the mounts for you through the container itself that is running. So it will mount the NFS, the correct NFS path into the pods for you. So you don't have to manage mounts on servers or anything like that. And it works in cloud providers like Linode and Amazon and all that. Anyways, so we need a server, and I was going to set this up beforehand, but I figured YOLO, let's see how much crazy things we can do in a live episode itself. And so I'm going to create a Linode. Just, this is probably not the most production worthy NFS always up server situation, but on the flip side, this is how I've built some clusters when I don't need that 99.999 reliability. I set up a server, give it enough storage, and then attach that to a cluster, which I'm going to do here. Debian's fine. I like Debian a lot. Dallas, Texas, because that's where our cluster's running. I'm going to give it a dedicated 4 gigs of RAM with 2 CPUs. Storage is something that we're not going to get into today. It's not a one-to-one levels thing. There's so many different variables that you have to think about when you're creating storage servers, whether it's inside your Kubernetes cluster with Rook and Ceph, whether it's an NFS server or a iSCSI SAN, anything that you're building, you're going to have to learn a lot about storage. But this is definitely adequate for one Drupal website that we're going to run today, probably even a few Drupal websites. But I'm going to create that server. I'm going to call it NFS server. I'll give it a root password. Let's see. Hopefully this field doesn't show it. Okay, good. And then I'll add my SSH key. And I'm going to give it a private IP address because what I'm going to do is I'm going to basically disable the ability for NFS to work on the public internet because that would be insane. And I'm sure somebody watching the stream would log into the server while or start copying files to the server during the episode and cause major problems. So I'm going to use a private IP address to allow this server to communicate with the cluster. So I'm going to create that. And if you were in Amazon or in another cloud that gives you a private network environment, you'd want to make sure that the server is running inside of somewhere where the Kubernetes cluster can see it. But here's the IP addresses. I'll make sure that I can connect to it in just a second here. I'll make a new window and say SSH root at that IP address, and it's probably not running yet, which it isn't. While it's launching, I will show you what we're going to do with it. So this was that Drupal persistent volume claim from episode 4, and the problem here is that we have read write once, and we want to make that read write many, but you can't do that with Linode's default volumes. You have to. That's why we're doing this NFS stuff. So I'm going to close that, and we're going to go to episode 5. And in episode 5, I have a Ansible playbook. Now, this is not Ansible 101. I did a whole series earlier this year on Ansible 101, so I'm not going to dive into what this is doing too deeply. But it's an Ansible automation playbook that configures an NFS server. And you can take a glance at what it's doing here. It's setting up a firewall, and it's setting up NFS server, and it's going to share this directory, home/NFS. And this is the export line that we're going to set up in NFS to share that directory. And it's just going to tell NFS, hey, take this directory, share it with the world. I don't care about authentication or anything like that because we're going to limit it only to other private servers in the same private network here. So it looks like this is running and it's letting me log in. So yes, I'll accept the host key and I can log in and make sure that it has, let's see, 74 gigs of space. I think that's going to be fine because today we're just going to upload one file that is, how big is this? 340 kilobytes. So I'll exit out of there, and I'm going to go out of here into episode 5 and NFS server. And what I need to do is edit the inventory file here to connect to this server. Right there. It'll connect as the root user to that server using my SSH key that I have set up on it. And it's going to run this playbook. So I'll go ahead and do that. Ansible playbook main. You might wonder too, like, how do I do this myself if you want to do the exact same setup? Well, in this repository, if you go to kube101.com and go to the Kubernetes 101 project and go to episode 5, you'll see all of this stuff is in here with convenient readmes that show you how to do everything that I'm doing right now. So it's doing that. It's setting up the firewall. And I'm going to go ahead and log into that server again too and cd into /home/NFS. And right now there's no files in here, but we'll show you what happens once we get the Kubernetes cluster connected to it. Someone is asking if it wouldn't work for 7,000 sites, but definitely 1 or 2. What about 100? That's something where you really have to benchmark. I've done a few clusters. One of them was running over 1,000 Drupal sites. Another one was running about 10. The one that had 10, we had no problems with one NFS server running, and it wasn't important to have super crazy high availability. The one with 1,000 was, and we actually ended up using Amazon with EFS for that, just because EFS scales up a lot better and has a lot better performance guarantees and things like that. Although there's other tricky situations with EFS that probably won't have time to talk about today, but I do have some blog posts on it. All right, so that NFS server is set up. If I say system control, well, I'll just say ps sox grep NFS. You can see that NFS is running. It's ready for connections. And according to the firewall rules here, it should be available to anything inside of this Linode environment, the 192.168 private network. And that means that our cluster can now start connecting to it. So I talked about the NFS Client Provisioner. We want to add it to our cluster. And as I said, that things have been renamed a little bit, and I was just going to grab the definitions off of the repository and the Kubernetes SIG external storage or whatever. You'll find that Kubernetes, in the Kubernetes community, renaming things is kind of like a hobby for people, I think. So a lot of times you'll set something up, and you'll go back for reference a few months later, and you'll be like, why is this repository archived? Is it like gone or something? And you find, no, they just renamed it to something else, and they moved the repository. That happens. It's really annoying. So one way that I kind of mitigate that happening all the time is I will either rely on Helm charts from people I trust, or I will download all that information into my cluster definitions, and I'll maintain it myself. And this again is something where, going way back to episode 1, when you build things in Kubernetes, you're taking on the responsibility for maintaining all the tools that you're using. And that's another reason why sometimes I choose something like NFS instead of Rook and Ceph, just because Rook and Ceph introduce maybe 10 or 20 different container images into your cluster. And are you going to take responsibility for all those container images' security, making sure they're updated, making sure your versions of everything's up to date? You can rely on other people to do that for you, but if you're running something important, you need to know what's going on in your cluster. You need to be able to have update plans for everything, and you need to test those, and you need to have, ideally for some situations, you're going to be managing all those container images yourself and building your own versions of some of them. So the more complexity you have and the more applications you run on top of Kubernetes to do cool stuff for you, the more your attack surface increases, the more things you have to maintain, the more things you have to update. So anyway, that's my little screed on keeping things as simple as you can. So I'm going to rely in this case on a Helm chart from C8s. I guess I don't know how to pronounce his name, but this user has a Helm chart that sets up the NFS Client Provisioner very simply. And it's a pretty simple system anyways. If you want to read more about it, look for the NFS Client Provisioner, which is now called the NFS Subdir Client Provisioner on GitHub, and you can read about how it works and see the code and everything. Anyway, I'm going to add that repo to Helm, like I do for any new repository I'm using in Helm. And then I'm going to install an instance of the NFS Client Provisioner into my cluster. I'm just going to do it in the default namespace. But you can find, this is in the README for this Helm chart. So you can look up this Helm chart, NFS Client Provisioner, under C8s. And all you have to do is give it the IP address and a path for the server, assuming that there's no other authentication layers going on here. And so I'm going to grab the private IP address of this server, which is here, the 192.168, paste it in there. The NFS path that I set for this mount is home/NFS. So I have that there. And then I'm going to use version 1.0.2, which is the latest, and all the other default options for this chart. So I'm going to hit OK. And then Helm is going to install this NFS Client Provisioner into the cluster. And now, if I say kubectl get storage class, I should see that there's now a new storage class called NFS Client. The default is to use this Linode block storage retain, and this only allows you to attach the volumes that Linodes creates in here. These volumes can only be attached to one pod at a time, or one node at a time. And so NFS Client is going to get us through that problem by allowing us to attach to multiple. And you can see this was just created 9 seconds ago as part of the NFS Client Provisioner. If I say kubectl get pods, you can see that the Client Provisioner is now running in my cluster, and it will keep running indefinitely, watching for any new NFS storage requests, and then it will put them into the cluster when it gets one. So that's the first step. I have the client provisioner running. Now I'm going to need to do one other thing, and that's just make 2 small tweaks to my Drupal persistent volume claim. So I'm going to go back into here. I have an updated version of it in here, but the only changes are these 2 lines right here and here. First, I can now switch to read write many if I'm going to use NFS, because it can mount it into multiple pods. So I'm not limited to mounting one pod and running one pod. And the other thing that I'm going to do is add a storage class name, because I want to specify, I want to use this new NFS client storage. I want to be able to store this in NFS and allow the client provisioner to give me that space and mount it into multiple pods. So that's all I had to do. I didn't have to make any changes to deployment. It's still using the same setup here in the volumes. This is unchanged from episode 4. The only 2 changes I had to make is specify a storage class for NFS and change this to read write many so that it can attach to multiple pods. So I'm going to do that, and I'm going to go ahead and create my Drupal namespace again because I just deleted it earlier. So I'm going to go ahead and create Drupal namespace, and this is something I haven't done yet. You can actually pass multiple files to kubectl when you're applying new configurations or deleting or updating or anything. So I'm just going to apply both. Whoops, I'm in the wrong directory. K8s, and then I'll try that again. And I'm going to apply the database and Drupal at the same time. And then I can say watch kubectl. Actually, we'll just do kubectl get deployment -n Drupal -w. And now it's going to watch for Drupal and MariaDB to get set up. So that should take a short amount of time. Drupal's already running. Usually MariaDB gets running before Drupal, so that's surprising to me. I guess maybe the download speed on that node to get the Drupal image was a little faster today than the MySQL one. Okay, now they're both running. So now I'm going to connect to Drupal, and hopefully, like I said earlier, I've done this 7 times total, and the only time it didn't work was when I was actually doing the live stream last week. So let's see if this works today. Kubectl get service -n Drupal and kubectl get nodes -o wide. This is to get the IP address and the port for Drupal. So I'm just going to grab one of those IPs. We'll go there, and the port is 31963, like that. And it should take me to Drupal's installer. We'll cross our fingers and hope this actually works today. All right, there's Drupal's installer. And I'm going to do standard. That's great. And one thing that we can check on while Drupal's installing is over in the server, if I ls, you can see that it now created the NFS Client Provisioner in the background all on its own, created this folder in the NFS share. And this folder will be mounted into those Drupal pods for the files directory. And if I look at this, if I copy this, and I look inside, these are the files that Drupal is seeing. So Drupal, when it sets up, it creates a config file. It creates a PHP folder that has some like rendered PHP files for templates and things. Styles contain some CSS that Drupal writes out to the file system. So Drupal's using this through the NFS server, and things are pretty fast still. So I'm going to say cube 101 scaling test. Test example.com. Super secure password, weak. How can admin be weak? It's a great password. What is it, SolarWinds? They use the password SolarWinds1234 or something like that. So admin is surely strong in that case. You gotta be kidding. All right, let's try kubectl delete namespace Drupal. Of course, it only happens when I'm doing a live stream. So now I've done it, what is this, 8 times, and the only 2 times it's failed is during the live stream. I can't believe it. SolarWinds123, so there wasn't a 4. So 1 less digit of entropy in there. All right, so Drupal's deleted. Let's do this again. This is ridiculous. If it happens again, I don't know. I just don't know. Might have to give up on Kubernetes entirely. All right, let's try applying it again. Oh wait, I need to create the namespace. Let's try applying this again. All right, and well, we can already get the IP address even if Drupal's not running yet. All right, they're not running yet. It shouldn't be a bandwidth issue. I saw your comment, Greg. It shouldn't be a bandwidth issue because my pipe is fat enough to handle a 500 kilobit stream, but I don't know. I don't know. Apparently I haven't sacrificed enough to the live demo god today. Maybe it's a sign that I could take a drink of water at least. The database is definitely running because it can't do any of this stuff without the database connection. And the annoying thing was I wanted to get the error messages between episodes just so I could know what happened so I could prevent it from happening again. And I couldn't get it to happen until now. So I couldn't get those error messages. So, all right, let's try this again. Cube 101 test. Test at example.com. Admin. All right. I'll set a default country. Who knows? Maybe that'll help something. I didn't do this yesterday, though. Save. Please work. You gotta be kidding. What? All right, let's do... I'm going to go in to debug this because this is just too weird. Too weird that it happens only during live streams. Kubectl exec-it-n Drupal. I need a pod name, though. Kubectl get pods-n Drupal. All right, so I'm going to log into this pod and look at the logs if I can and see what's going on. Drupal, that pod, bash. Yeah, that's deprecated, whatever. I'll do the -- in the future. All right, cd var log apache 2 cat error nothing cat other nothing. What? Oh, it's logging to output, but hold on. Let's see. Oh, there's no other logs in here. All right, let's try kubectl log -n Drupal. No. -n Drupal, and what is the pod again? This is so annoying. Logs. Logs. Get hello. Wait a second. Why is it trying to do hello? Is something must be calling this elsewhere. Maybe somebody on the stream or something. The problem is PHP's logs are not visible to me here. I don't know. It's because it's going through Apache. All right, let me try. I'm going to try deleting this one more time and recreating it. I just don't understand why this happens only during the live stream. Is this my IP? Oh, where? In here? That's not. Oh, you know, I think that might be a check. Let's see. Hello. No. Hello. No. I don't know what that check is coming from, but it's coming from the server itself. No. Yeah? It's coming from Mozilla Linux x86-64. I don't know where that's coming from. Anyway, let's see. Yeah, it could be somebody accessing the site during the stream. That actually is true, because if somebody accesses the site during the setup process while I'm also installing it, that could actually cause an issue, which I never really thought about, but that does happen sometimes because the files can be either owned by the wrong user that Drupal sets up, or it can cause a weird issue in the installer. There's a way that I can work around that. I'm just going to try creating this one more time, and maybe don't try accessing the site while I'm doing it, and we'll see if that helps at all. This is why we don't do live demos if you can avoid it, but it's more fun this way because you get to see my brain go a little crazy and try to figure out what's going on. All right, so I created that. Let's try installing again. That's not going to be the right. That's not going to be correct. Where's get service? Okay. 3409. This is also a good illustration of why when you're building something, like if you're going to build a Drupal hosting environment and have multiple Drupal sites and have them set up and things, you don't want to have something set up where anyone in the general public can come in and do things like install your Drupal site. You want to have that automated on the back end before it's exposed to the public. Oh, yeah, somebody's saying set it up to the side so nobody can see the IP address. There is a health check defined in the pod definition. Where is it? It's just checking if port 80 is working. And now I can't even get anything. Oh, there it is. Okay. Let's try this one more time. Try not to access the site while I'm doing it. We'll see what happens. Like in this period here, when Drupal's actually doing the installation, if other people access the site at certain points, it can cause an issue. And yes, Fayez, something is wrong somewhere, that is for sure. All right, let's try this. Test at example.com. All right, save. Please work. If it doesn't work, there's other things we can do, but it's not as impressive as you don't. Okay, yay, finally. It worked. All right, so Drupal's working. Things are all happy here. The site looks good. I'm going to go ahead and create one node on the site, an article. Yay, it actually is running this time. And I'm going to add the episode thumbnail because it's so pretty. I love to see my face and talk to myself. All right, Jeff in episode 5. We'll align it to the center. That's great. All right, so the cool thing here is what we just did was uploaded a file to our Drupal site. And when I save this, it's gonna write it to the file system in that path. So if I go back over here, let's see. Yeah, oh, I'm in the wrong folder there. So every time that you create a new PVC, it's going to create a new folder here until you clean that up. So there's a new one, and you can see it's archived. So you can actually get to old sites files, old Kubernetes application files in here until you clean things up. So I'm going to go into this new site one, and if I go to inline images and see that here's the file that I uploaded. So it's all working and it's all nice. Now this is still running on one Drupal instance, and I'll do LAH. So this is 330 kilobytes, so a tiny file for our 80 gigabytes of storage. But it is working, so that's cool. I'm going to go ahead and exit out of the NFS server because we don't need to see that anymore. But it's great that our site is actually working, our wonderful Drupal test site. And we want to actually see if scaling it up now works and if it makes any difference for performance. And that's another thing that people often do. You might start adding in things and scaling up and things when you don't necessarily need to. And some people are like, well, I need to have 5 instances running at all times. And what you do is you basically waste a bunch of money because you have to have bigger servers to run 5 instances and things when you really could run with 1 or 2 at a time and then scale up when you need to. So I always like to benchmark before, during, and after I make any changes. So what I'm going to do is use Apache Bench, which you can install on pretty much any system. And it's AB. So I'm going to use Apache Bench -n 500. So I'm going to make 500 requests using 10 simultaneous connections to this Drupal site just to get a baseline of performance. And what did I enter wrong here? -nc/. There we go. Forgot the final slash there. So I'm gonna make 500 requests to the site just to see how many requests per second I can make. That's a good baseline for HTTP applications like Drupal. And you can see that it's doing about 47 requests per second. Now this is going through Drupal's caching layers. So if I do it again, it probably will be a little bit faster on the second run because Drupal's now serving all cached requests using its little internal PHP caching backend. And you can see it's a little higher, 56 requests per second. So now I want to test scaling up Drupal and make sure that it actually works. So I'm going to say kubectl edit deployment -n Drupal. And it's the Drupal deployment that we're editing. So I'm going to go down here to replicas, which is here, and change that to 3. Actually, let's go a little faster. Let's go up to 5. 5. All right. And if I say watch kubectl get pods -n Drupal, we should see that there are new ones scaling up. It's initializing a couple. These two should be running pretty soon here. Of course, it's a live demo, so they probably will just sit here and init status and make me look like a fool. But you can also check on the status. There they are, they're running. You can also say kubectl get deployment -n Drupal, not Drupal. And it's saying that there's 4 of 5 ready. So I guess that HTTP check is still not up. So we'll wait until that's ready with, we'll go to -w to watch it. There it is, 5 out of 5 are ready. Okay, so I'm gonna run that same Apache Bench test with 5 instances running. Now, each one of these instances has to build its little PHP cache internally. So on the first request, it's gonna do that. So this first one, actually, it's a lot faster. I wasn't expecting to be that fast right away. But as I said, the first request to each instance will hit, we'll start building that cache up, and then it should go a little bit faster over time. So 109, 110. So the first run with 1 pod, we were getting 50 requests per second. And obviously 50 to 100 is not scaling linearly with the number of pods that we have. And that's because there's a lot of different layers to an application like Drupal. There's the database, there's the request routing, and PHP is not the only performance bottleneck for a Drupal site. But that's the one that we're trying to resolve right now. And the cool thing is we're scaling Drupal and it's working and it's giving us better performance. So we know that when we need it, we can scale up Drupal, scale up the Drupal pods and get better performance out of our site. So now the next step is we want to make it so that Kubernetes can do that for us. So we don't have to sit around and be like, oh my gosh, we're getting more traffic. Somebody go edit the Drupal deployment and scale it up. We want to use Kubernetes built-in tools to do it for us. So I'm going to go ahead and edit this deployment again and scale it back down to 1 for now. Whoops. Oh, oh boy, I got into a mode and I hit the wrong key now. I'm going to quit out of here and try this again. I hit the wrong key in Vim, and then it's one of those things where whoops, oh goodness. This is why my brain needs to either switch to Vim entirely and switch Sublime Text over to Vim mode, or maybe just, oh my goodness. Now I can't even type. Or stop using Vim on the command line during these live demos. All right, so Drupal should now be, if I say get deployment, Drupal should be getting down to 1. Okay, so Kubernetes is pretty quick about scaling up and down, and NFS attaching and detaching is usually very fast, unless your NFS server goes away. Then it gets really slow, and you have a lot of weird issues. And yes, Marco is saying, can you use kubectl scale deployment? I can do that too. I usually like to edit the files because my brain is working in the YAML and I don't have all of kubectl's various features memorized. So anyway, you can use kubectl to actually do the scaling yourself too. And it's a little bit easier that way. And you could even have automate that in some system or something. But we're going to use something called Horizontal Pod Autoscaling. But I have to emphasize that just like many other things in Kubernetes, a lot of people are like, oh, Kubernetes scales and does everything for you automatically. It's not automatic out of the box. Most of the time, I actually haven't ever set up a cluster where I could just start using pod autoscaling out of the box. I've always had to do something. And usually that something is installing the metrics server, which is a tool that runs in your cluster that gets usage information for memory and CPU for every pod and every node that's running. So you need metrics server, or you can also use other tools like Prometheus and things like that to monitor that. But Kubernetes pod autoscaler uses the metrics server to be able to know, hey, this pod is getting a lot of load. I need to scale up or scale down or something. So that's the case with Linode as well. Linode doesn't include metrics server out of the box. And I don't think Amazon might now, but I don't think they did last time I tried it. Minikube doesn't include it out of the box. Most Kubernetes distributions and cloud providers don't provide this tool out of the box. So if you go to add horizontal pod autoscaling, you'll set it up and you'll be like, why is it not working? And then you have to dig around and you're like, oh, it needs to actually know what pods are doing. So once you have it running, and you can check really quick on any cluster, you can say kubectl top nodes. And if it says metrics API not available, that means metrics server is not available and not running. You can get metrics server directly from the project on GitHub. It'll work that way with many clusters. With Linode, there's actually a couple, I think, yeah, there's a couple changes that you need to do for Linode itself. And I have those in this file here. These settings are used to make sure that metric server can get the right resources and connect to Kubernetes API the right way. And this is just a way, instead of specifying this on the command line with Helm, you can give Helm a values file like this and pass this values file to Helm, and then it'll apply those values to a Helm chart for you. So that's what I'm going to do here. We're going to apply those values. I'm going to use Bitnami's metric server chart just because it's really simple. I trust Bitnami. I use a lot of their charts when I'm doing testing and things, and I've never run into any issues. So I'm going to add the Bitnami chart repo, and then I'm going to install their metric server chart into my into my cluster in the default namespace. And again, here's where I pass this values file. So instead of specifying each of these options on the command line, I can just put them in a values file like this and then pass it to Helm, and it will apply those values into the chart. And I'm in the wrong directory. So let me actually do this the right way, and then it'll work. And Murdad, I might be butchering your name there, is asking about increasing the DB replicas. We'll get there, don't worry. All right, so metric server is being deployed. Let's check if it's running. I could check if the pod is running, but I'm just going to run this and see if it's getting into value. And it is, so that's great. And we're seeing that it looks like, I'm guessing some people on the live stream are actually accessing the Drupal site because the CPU is actually getting hit a little bit. And when I was doing the testing for this, the CPU is like 1M, which is like 0.001 CPU is being used. So it is getting hit a little bit, possibly some public traffic out there. But you can see that it's pretty lightweight right now. Things aren't getting hammered too hard. But the good thing is we know that the metric server is working because it's giving back information. And I can do the same thing for pods in the Drupal namespace. And it's going to tell me that Drupal is actually not using much. So this is 1 milli, so 0.001 CPU core is being used by Drupal right now. And not much memory either. I forget what we allocated. We told Drupal it could use, what, half of a CPU core and 512 megs of RAM, so we're well under those limits. We don't really need to scale Drupal right now. It's not a big deal, but we might want to start scaling Drupal at some point. And typically, Drupal will either consume all your memory or all your CPU or both. But for this case, I just want to see if the CPU starts hitting 50% or more, I want Kubernetes to start scaling up for me. And so I'm going to use a kubectl command, kubectl autoscale. So I just mentioned earlier, I like to do this all in YAML, and now I'm doing the kubectl command again. So anyway, I'll talk about the YAML way of doing this in just a minute. But the kubectl autoscale will create an autoscaling setup for pods in a deployment or in a replica set, which we haven't talked about yet, but this is a deployment, the Drupal deployment in the Drupal namespace. And you can give it a number of different options. I'm just going to give it a few. I'm going to say I want a minimum of 1 pod running at all times just to save costs. You know, the more pods you run, the more hardware you're going to need for your cluster. But I want it to get up to 8 pods, and some people would not put an upper limit. I almost always put upper limits on things for resource usage, just because if you don't do that, sometimes you can run into problems where it's like it scales to the moon all of a sudden because of some weird condition. Thanks very much, Remy. It scales to the moon all of a sudden, and then your servers start thrashing and having issues because you didn't put an upper limit on things. And then the last thing is the CPU percent. So when Drupal starts consuming at least 50% of the CPU, so right now it's if its limit is 500 and it's only using 1, it's using, what is that, like 0.05% or whatever. So once it starts using 250 milli of CPU cores, then it's going to start considering scaling up. But it's not going to do it right away. So I'm going to create this scaling. I'm going to say kubectl get HPA. It's the Horizontal Pod Autoscaler in the Drupal namespace. And it's called Drupal. With many of these kubectl commands, it just names it after the deployment you're working on. So I'm going to get that. And it's right now it says target is unknown out of 50%. So the Horizontal Pod Autoscaler is not an instant thing. So it doesn't know. It's not like running top on your computer and it immediately is showing you information. It has to gather the information and kind of put it together. And so it takes like 5 or 10 seconds after something happens before it can start reacting. And so you can see the target is 0%. It's not using any CPU at all, basically. It's like 0.05 or something, but it rounds to 0%. So if I say watch, well, I'll just do the command and watch that. And I'll go ahead and also create a new window, and I'll connect to my Linode cluster, and I'll say watch kubectl get top pods-n Drupal. So we're going to watch this. Right now, Drupal's using a little bit. One way to quickly hammer the heck, somebody's already logged into the site as admin because I didn't change the password. Yeah, so that's fun. Please don't kill the site before we're finished with the episode. But if you want to really kill Drupal quickly, go to extend, and that's why you should always use good passwords. Probably not use the password admin while you're actually doing a live demo. Anyways, this page will actually load every module file in Drupal into PHP. So it's a page that kind of hammers the heck out of Drupal. So don't use this for bad, but if you ever find a way to get this page to load on someone's site and you can script it and automate it, you can really take a lot of performance out of their site by loading it over and over again. You shouldn't be able to load it unless you have an admin password. So anyway, this page takes a lot of power for Drupal to run, and we want to call it. So what I'm going to do is I'm going to use Apache Bench over here, and I'm going to say ab-n, and we'll give it 1,000 this time. We'll call 1,000 times. I'm going to use 3 connections because I don't want to torture Drupal too much. And then I'm going to pass a session cookie, and that's how Drupal uses its authentication. So we need to make an authenticated call to this, and I'm going to copy this this cookie out. This is the session key for this user. And if you want to try copying or typing this in yourself, good luck. You can do it. Someone else has already logged in as admin. Whoops, I missed the last 2 characters there. Let's try this again. ab-n 1000-c3-c, and oh man, my computer's starting to slow down here. This isn't too good. Come on, you can make it through to the end. I have faith in you. Only a little bit though, because I have to. One issue with using a Mac for streaming in OBS is it cannot use the GPU for acceleration, so my CPU just gets murdered more and more as the time goes on. All right, so I'm going to do that and call this page, so admin/modules. And we're going to go ahead and fire that off, and while this is running, we'll monitor things. And like I said, it's not going to be immediate, so you're not, some other people must be loading the site right now. So it's not going to react immediately, and there's a couple good reasons for that. The horizontal pod autoscaler is built in a way to prevent that thrashing. And it can be a real problem in your cluster. If you built a scaler that said the second that it goes above 50% CPU usage, I'm going to start scaling up. And then like the second after it goes below, I'm going to scale down. You're going to start having problems where the scheduler, the Kubernetes scheduler, starts having issues because it can't keep up with scaling up and down a lot, especially if you're like right on the target limit. And so the Kubernetes scheduler has an algorithm that it uses to say, you know, when it ramps up the CPU to 50% or beyond, wait a little time before it starts scaling up. So you're going to run into issues if you always under provision what you need. So if your traffic is normally around 40 or 50% CPU usage and your site is fast enough, but then every once in a while you get a little peak, you're going to want to actually have 2 replicas or 3 replicas, have a little bit of extra capacity so that you can handle those little blips. But then when there's something major like this, like what I'm doing right now, and someone else might be doing the same thing on their system, causing more load, you can see that the performance now is declining. Drupal is probably a lot slower. If I refresh this page, it's actually not performing too badly, but I think that's because the replicas are already there's already 7. And another thing to note is that kubectl top will lag things a little bit. So now it's showing all of them, but those pods were actually running about probably 60 seconds to 2 minutes ago. A couple minutes ago, they probably started up. Kubectl lags a little bit, and a lot of times your monitoring tools will also lag a tiny bit from the reality of your cluster, just because the systems underneath, like metric server and Prometheus and things, often take 5, 10, 20, 30, even 60 seconds before things start going into their little dashboards and going around like that. So let's see. So it worked. We have, this is saying 7 replicas, but let's see, 1, 2, 3, 4, 5, 6, 7. I guess the thing is that the the pod autoscaler has seen this level of traffic is able to be served around that target, it'll probably add another replica if we go in there and do that. But you can see that the Apache bench has only gone through about 300 requests. That's because this page is a crazy page to load for Drupal if you're trying to do it super fast many times. So I'm going to Control-C out of here and let the load back off now. And you can see that it was only getting 2.44 requests per second. So that's the same if I'm doing this in here. You can see it takes like almost a second to load a page. So as time goes on and there's more nodes here, and there's more pods running, it should be able to run that page a little bit faster. There's still going to be the what is it called? The database layer and the request routing layer, things like that are still going to add some overhead. So it's not like a magic bullet just to scale up Drupal. So if I go here, now it's doing 2.97. So it increased a little bit in speed. But if I back off now and I stop loading things, it's going to take, like I said, 30 seconds to a minute for this target percentage to go back down. And then Kubernetes is going to wait. The horizontal pod autoscaler will wait a configured period. So actually, it just added another replica. It's going to wait for a period of time before it starts backing off and removing these pods that it created. And that's, again, to prevent that thrashing. That particular period, the cooldown period that Kubernetes uses, is configurable, but most cloud providers don't allow you to configure that on your own. They set up your Kubernetes cluster, and it's something you have to set up at the cluster setup time, and so you might not have control over it. But typically speaking, that value is okay. 5 minutes is fine. The worst thing that could happen is you're using a few more resources for that short amount of time. Now, another thing that I didn't touch on at all today, and I probably won't touch on during this Kubernetes 101 series, is node autoscaling or vertical autoscaling. Those are things that are also possible to do. They add a little bit more complexity, and especially, well, actually for both of those, you can run into some major issues if you set things up wrong and all of a sudden you go from 1 node to 100 nodes and they keep running for a few days. Because then you have to pay thousands and thousands of dollars all of a sudden. So always be careful when you set up scaling things that can accidentally increase your costs without you knowing about them, and set up things like billing alerts. All right, so it looks like these pods are all back down to almost no usage at all. The target is 1% out of 50 now, and that's probably whoever's logged in as admin over here making changes on the site. And after a couple more minutes, the replicas will start decreasing. You'll see these pods dropping off. And that's just the horizontal pod autoscaler doing its thing. So that is for Drupal. And someone mentioned in the live chat a little bit ago about the databases. So why can't I do the same thing with the database? You'll notice that the database has a similar setup. It has a persistent volume claim here, and it's read write once. And I could change this to use NFS. Some people do that, and I've actually done that sometimes in my Raspberry Pi clusters just for simplicity's sake, because Raspberry Pis don't... I tried running Rook on my Raspberry Pis, and it was not fun, so I stopped trying that, and I switched to NFS. And you can run databases on NFS, but it's not great, and performance will suffer measurably. A lot more so than Drupal, because with Drupal, when I go to my homepage here, and see the beautiful green header that somebody set up, and someone is from Russia with love, web architect. So when I go here and see these things, everything in Drupal that's loaded, all these little graphics and things, that's all loaded from the pod file system, which is super fast. It's using the storage on the node. The only thing that's loading off NFS is this image. So if I open this image in a new tab, this is all that's loading off NFS that has to go over the network. And you can load this very quickly over and over again. NFS is great for that kind of usage pattern. With a database, every time that I click on a page in Drupal, it's going to make 100, 200 different database calls. Even if that's all cached and everything, that's a lot of stuff to go over NFS. And when you're writing data to a database, that's even worse when you try doing it over the network. Like I said, it's possible. Not a great idea, though. And even with Rook, I wouldn't recommend running a database over a Rook Ceph file system or Gluster or anything like that. Again, I've done these things, but they're not good ideas for a few different reasons, and we won't get too deep into all the reasons there. But there are ways to scale databases in Kubernetes. So I'm going to, before I mention some of the other ways to do it, one of the things that you can get into, if you want to do this all by hand and change this deployment and add replicas and things, you'll have to do a lot of things like make sure that the database replicas aren't on the same node. So you have to add node taints and node affiliation settings. You might want to consider in Linode adding a dedicated pool of database servers in your cluster. So you'd go down here and you'd say add a node pool, and you'd want to make sure that you have more beefy instances. If you're running in Amazon, you'd want to use IO1, or I think, what is there? There's like GP3 or something. There's a new storage class that would be good for higher IOPS that databases need. But it's a lot more complexity to try to do that. So there's a few different ways that we can solve that. One of them is using an in-cluster high availability database setup. So there's Vitesse is one of the most popular solutions. It's a CNCF incubator project. Will probably be graduated at some point, but it runs a MySQL server setup in your cluster that has MySQL clustering. So it can have a master and multiple slaves or whatever kind of setup you want for that better availability. It gets a little bit complicated, and just like Rook and CephFS and Ceph, your architecture diagram starts getting bigger and bigger. That's one thing I really dislike about the Kubernetes community. I think some people in Kubernetes land I call them architecture knots. They like to have this crazy massive architecture diagram. This is like junior level here. They want to have an architecture diagram that's like 18 pages long, showing all the different things that are going on in their cluster. I hate that. It feels like once it gets past something that you could convey in one page of image, your architecture is complicated enough that it needs to be broken up in some way. And we move into microservices, but then we build a system that you can't even understand. That's not the way, as in Star Wars. This is the way. Something simple that you can understand. If you need to go into this kind of setup, you need to have enough specialty in your team to be able to manage all that complexity. And if you have a team of two DevOps admin type people, and you're running a Kubernetes cluster with 5,000 apps in it, things don't scale that well. Anyways, Vitesse is kind of like that. Bitnami has a Helm chart for high availability MariaDB that's also very popular and can work. Same kind of setup where you can have a cluster inside your cluster. And the way that they work is instead of having one instance with replicas, it has a deployment that has like a master and a slave, and it has extra logic that you can use in their containers that allow the containers themselves to see, oh, the master's gone, I'm going to switch. That kind of setup. This is what's the Press Labs. Press Labs also has a MySQL cluster operator that you can deploy to your cluster. So these are options if you want to do that work, if you want to know that the complexity and manage it. Some teams can do that. Other teams, if you don't have somebody who is skilled with databases and managing them in a Kubernetes cluster, and again, if you don't know how to do it outside a Kubernetes cluster, you should not try doing this inside the Kubernetes cluster. It's just going to be way harder. If you don't have somebody on your team who understands how to set up a high availability MySQL database cluster or whatever, Postgres or something, and get it running and tune it and see, do backups and all that, you can't jump into Kubernetes and say, yeah, we can start running Kubernetes MySQL clusters. No, that's not how this works. You have to understand how it works at the base level, and then you can start doing it in Kubernetes for convenience. But the other option that I typically recommend, and in any important high availability situation that I've run, they all use a cloud provider's high availability database system. So there's Amazon Aurora or RDS, there's Google Cloud, Cloud SQL storage, DigitalOcean has managed MySQL. These are great options because there's teams of people at these providers that work on these systems to make sure that their uptime is amazing and that they're fast and that they're optimized for the storage that they use. If you don't rely on their setups, then you have to figure out all those things on your own. And like I said, if you don't have people on your team that can do all this stuff, not a great idea to try to start setting up your own clusters. On the flip side, I have set up on the smaller Drupal cluster that I set up one time, we did just use one MySQL instance like I have set up over here per site, and it works fine. It's still working great today. if you don't need to have 99.999 availability, you don't need to have multi-region failover and all these kind of things, this works fine. I mean, my jeffgeerling.com, which I'm sure is probably going to go down the second I try loading it. jeffgeerling.com has 99.998% uptime over the past year, and it's running on a VPS that's one server with LAMP, with MySQL, LAMP, MySQL, Nginx, and PHP running on it. It works. Simplicity has its virtues, and one of those virtues is that when things do go wrong, it's actually easier to recover sometimes than when you have a crazy complicated situation. Anyways, tangent there. Another option is if your application supports it, if you can change your application to use a different type of database. This is the logo for CockroachDB. It's another option to use a cloud native database, which scales a little bit easier inside Kubernetes. You don't have to use special tools. They're built to run inside Kubernetes with high availability, multi-region failover, all these special, wonderful features and things that C-level execs love hearing. So that's another option for you to use something like CockroachDB. And it's not the only one. There's other ones too. But that's an option if you can change your application. Now, Drupal doesn't work with it, at least not as far as I can tell. And a lot of applications that you're going to run can't work with it. So again, I typically recommend using a cloud provider system. If you're going to be using Kubernetes and you do need those availability guarantees, and you do need snapshotting and easy restoration and things, sometimes, so these things cost more money. That's the biggest argument against them. It definitely costs more money to use a managed system like this. For databases in particular, it might be worth it, depending on your needs. On the flip side, having a simple setup like this saves some money, and it might be okay. You really have to evaluate the needs of your own system. And speaking of keeping things simple for you, today's sponsor is Amazy.io. And the cool thing about them, the past couple episodes I've been talking about Drupal, they are specialists with Drupal, but also other applications too. But they will take away a lot of the complexity of setting up all of your Kubernetes cluster backend stuff, the storage and the database, all the things that we've run into problems with today. And they will make sure that it's easier for you to host things, easier for you to deploy applications. And especially for Drupal, they make a system called Lagoon. It doesn't only work with Drupal, but coming from my background as a Drupal developer, it's a great solution for Drupal in particular. They have tools that help you to manage your applications in an easy way and manage the back end for you, so you don't have to worry about those things. You don't have to have people on your team that are dedicated sysadmins and DevOps people that are only working on your, getting Kubernetes working correctly. You can work on your applications. They'll work on the hosting. Great company. Glad to have them as a sponsor, so check them out. And that's all I'm going to talk about with databases today. I'm not going to switch my little cluster to use one of these things, but check them out if you're going, especially if you use one of the cloud providers that has a managed SQL offering. It's a good option and will save you so much grief and so much time. The last couple things we're going to do, I'm a little bit over time today. But, oh goodness, I just went into full screen mode and lost everything. Hold on a second. Let me go back to slideshow and window. So a couple weeks ago, I think this was, maybe last week, Deef Dragon, so thanks for your comment there, said it'd be great if you had some Q&As in these things. And I did that for my Ansible 101. And I think it's a great little section here. So I'm going to answer a few of the questions that we had during this live stream. And I won't answer them all because we're already a little bit over time, and I want to let some of the people who are watching this late at night get some sleep, because sleep is always a helpful thing when you're dealing with Kubernetes clusters. And then at the end of this, I'll also give away 5 copies of the book. And special thanks to Tim Montgomery, who's Killer Goalie on Twitter. He sent me, he said, hey, I want you to give away some books. And I'm like, sweet, I'll do that. And so he sent me a little money for a little Christmas gift for 5 different people. So stick around for a couple minutes and I'll get to that. But a few questions and answers. Let me, I will open up a new window in here and I'll paste them in. So first question is, are you running your Cube 101 website in your home Raspberry Pi cluster? Unfortunately, not right now. I am working on some longer term things with Raspberry Pis, You might have noticed on my YouTube channel, I'm doing a lot of Compute Module 4 testing. Here's my little Compute Module 4. I'm doing testing with storage. I'm doing testing with running Kubernetes on different Raspberry Pi clusters. I'm waiting for the Turing Pi 2 to come out, and I might do things before then because I've been starting to get some cool boards like this, which allow me to do different clustering options. And I'm going to be setting up a cluster that will be running some more production stuff. Right now, the only thing that's running in my house is pydramble.com. So that's pydramble.com. Everything else is running in the cloud somewhere. Okay, another question. There was a question about database block storage, and I already mentioned you could do that in NFS. Not a great idea. Consider using one of the other systems. When do you use camel case or snake case in your YAML files? That's something that you have to figure out on your own for your own team. Typically in Kubernetes, things use camel case like that. But I work with Kubernetes and Ansible and some other systems, Drupal, and it really depends on the system that you're using. I typically try to use whatever the convention is. So if I go over here and say, let me get out of here. If I say kubectl edit deployment Drupal, you can look in here. They have, actually, there's some things with dashes, but typically it's camel case like this. So, if I'm working purely in Kubernetes, I'll typically stick with that. I'll try to use camel case like this for any custom variables that I use. But if I'm in Ansible, I typically use snake case, and that's my own convention, but it's pretty typical across the Ansible community. So, use whatever style suits you, but try to be consistent. Adding quotas to NFS directories. It is possible to do that. I don't believe with the NFS Client Provisioner. It might be. I haven't actually done that with the Client Provisioner. That's a good question. That's something that would be good to take a look at. If anybody in the live chat knows if you can add quotas with the NFS Client Provisioner, that'd be interesting to know. Otherwise, if there's a way to do it on the NFS server itself, there are ways to do it that way. It's a little more convoluted, but it would be cool to be able to do it in Kubernetes. Like say this pod can only use this much storage I/O capacity. You can say, like when we define the persistent volume claim itself up here, we are saying I want 1 gigabyte. But I believe if I logged into that pod, kubectl exec, we'll log into that pod here. I'll use the --bash and cd, and well, where are we? Cd into web, sites, default files. So there's our files directory, and if I say df.h, where is it? Sites default files. So it's given me 74 gigs. So obviously it's not enforcing a limit of 1 gigabyte. I don't think it is, at least. So anyway, that's something that you can definitely investigate. Maybe I'll take a deeper look at that for a future episode. What's on the t-shirt today? That is a question from Clifford. Today I have, there it is, Drupal. So here, let me go to this camera. See, it's funny that you mentioned that. This shirt, I bought it from DrupalCon Global this year. Most DrupalCons, they have a shop in the middle of the DrupalCon exhibitor hall, and they only have a couple types of shirts. And I have always wanted an orange Drupal shirt. I always have like blue or white or whatever. But this year they had a generic t-shirt retail or something, so you could choose your color. So I got orange, and I'm not Dutch, I'm American, but my family comes from the Netherlands. The Geerling family name comes from there. So I like having orange shirts. You might notice that some of my videos I'm wearing my Netherlands jerseys of different vintages and some other orange shirts that I have. But anyway, this is, I guess, my like Drupal Dutch version of my shirt. And yes, if it were a red shirt, then yes, I would probably not be so calm right now. Let's see. Any good options for block storage on Raspberry Pi clusters? There are a few ways to do it. It's difficult to set them up, and they're more complicated. Like I said, I typically use NFS on my Raspberry Pi clusters just for simplicity. But you could use something like OpenEBS, I believe, might work on it and give you, simple block storage like you would on an Amazon cluster. But yeah, we might talk about that a little bit more next year in the Kubernetes on Raspberry Pi episode that we talk about. All right, so the final thing, which I'm sure everybody has been waiting for, these are the 5 people. So the way that this works, Tim Montgomery, Killer Goalie on Twitter, sent me a little Christmas gift of money to give away 5 books for oh, thank you very much, Kegmag or Segmag or something. Merry Christmas to you too. Yeah, the pain and suffering on this live stream. So the 5 people that I'm about to post here are the 5 people who commented the quickest after the live stream actually started. So after the live stream countdown ended and my face popped up on the screen and I said hello, these are the 5 people who commented first here. So Chris Addis, Snowdrop Productions, Murdad Nasiri, Vimarsh, and again, I am the worst person in the world with saying names, and Manuel Eller. If you guys want to message me on Twitter or somehow through Facebook, I think not Facebook, oh my gosh, YouTube. I think on the YouTube About page on my channel, there's actually an email address there, or on my website on the About page. Send me a message, let me know, and I'll get you a copy of the book. If you already have the book, let me know, and I will. I'll give away your free code for the book to somebody else. But this is for the Kubernetes 101 book, which, by the way, if you don't get a free copy, if your name is not in this list, it's still only $5 on LeanPub. So go to ansibleforkubernetes.com, get it there, and that's. Oh my goodness, you can't see my screen. There you go. Sorry, these are the people who won. I switched off to show you my shirt, and then I didn't switch back. So there you go. Those are the 5 people. Thank you very much. And yes, the Netherlands are the. I'm not going to start any kind of a battle between the different countries in the world, but it is a great place. I got to visit it one time before the pandemic, and would love to go back there again. There are a lot of places I'd love to go someday, maybe in the next year or two, when things open up again. But the next episode is going to be next year. So I'm taking a little break to give my throat a little rest and focus on a few other things for the end of the year. But next year, we're going to talk about a few other things. One of the most annoying things about this whole process is right now this website can be accessed at 45.79.50.62, which is ridiculous. I'm not going to tell my site's visitors to go there and go to this port number. So we want to set up Ingress, which is going to allow us to use DNS names to access our site and not have to use node ports and things like that. So we're going to talk about Ingress, DNS. Another thing that Drupal needs to run well is it needs to be able to run cron, which is a way for Drupal to run automated jobs that kind of clean up the file system and clean up Drupal's database. And a lot of systems need this kind of thing. You need automated jobs to run over time. So we're going to talk about setting up cron for Drupal inside of Kubernetes in an automated way. And we're going to try to figure out what to do with Drupal's logs. Like when I started getting those error messages, it was hard for me to debug that because it's inside Kubernetes. You can't just log in and see a log file somewhere. It's in containers and there might be different things. So we want to get this log in a way that we can see it through Kubernetes easily. So we're going to work on how we can do that as well. So that's all coming up. Episode 6, January 6th. Please subscribe to the channel. We will talk then, and until then, I am Jeff Kierling.